is to define the bulk unit weight, which is given by gamma bulk, and to derive an expression for gamma dry and gamma sat, which is the saturated unit rate and the dry unit weight. So the first thing we're going to do is we're going to look at a sample of soil. Okay, so our sample of soil, as we know, has solid particles. It's going to have air. It's going to have water, which is given by blue, and it's also going to have pockets of air in red. Okay, so there's our soil sample. So what we can say is, we can say that the bulk unit weight, so this is the unit weight of this sample will be the weight on the volume, okay, which we can break down further as the weight of the solid plus the weight of the water divided by the volume of air plus volume of water plus volume of solid. You'll notice that there's no weight of air because, as we said in the previous video, we don't include the weight of air because it is nothing in comparison to these weights. So I'm not going to go on how we derive it, but you're not going to be using this expression much. The main expression we're going to be working with is G outside of 1 plus M on top of 1 plus E gamma of water. Okay, so the bulk unit weight is given by this formula. So the specific gravity outside of 1 plus the moisture content times the bulk unit weight of water over 1 plus the void ratio. Okay, so as you can see, this soil sample is dependent on the amount of moisture. Okay, so we're going to be looking now at a completely dry sample and a completely saturated sample, and everything else in between would use this formula. But if we now shoot off here and we're looking at a fully dry sample, okay, so we can say our sample is fully dry when its saturation is equal to 0, right, which is the volume of water on the volume of voids. In other words, there's no water in our sample, it's completely dry. Okay, so graphically we could draw it like this. It would just be a sample just with solid particles. Okay, so there's going to be no water in this particle. So we also know this relationship where E equals mg on S. We saw this one in the previous video and I said it's very important. We can rearrange this in terms of M, so we get ES on G, right? Now watch this. I'm going to say that our unit weight, we saw before, at any point is given by G outside of 1 plus M gamma W on 1 plus E. Okay, I'm now going to substitute in for M, so I get G outside of 1 plus M is ES on G gamma W on 1 plus E. Okay, now because we're defining a fully dry sample, our saturation is 0, which means this is going to be 0, S will be 0 here, which means it'll cancel out, so we will be left with G outside of 1 plus E outside of gamma W, and this we define as gamma dry. Okay, so the bulk unit weight of a fully dry sample is the specific gravity over 1 plus the void ratio and times that by gamma water. So you only can use this if the sample is fully dry, i.e. its saturation is 0. Okay, now we can go to the other side where we have a fully saturated sample. Okay, so in other words, our S will equal 1, okay, because the volume of the water on the volume of voids, if it's fully saturated, that means all the voids are taken up by water. So there's no air in our sample now, it's all water. So if I were to draw this, it would look something like this. Okay, it's only water in here, there's no air. Right? So similarly, I can define gamma as G outside of 1 plus M gamma W on 1 plus E. So this is the general formula, gamma bulk at any point. But now we have a specific condition. We have G outside of 1, so I'm just going to substitute in ES on G just like I did before. ES on G outside of gamma W on 1 plus E. But now our S equals 1. Okay, so I'm going to substitute that in there. So we get G outside of 1 plus S is 1, so E on G gamma W on 1 plus E. And now if I expand this out, we're going to get G plus EG on G will just be E. So it's G plus E on 1 plus E outside of gamma W, and we're going to define this as gamma sat. Okay, so we have three main definitions. We have gamma bulk equals G outside of 1 plus M gamma W 1 plus E. So this is the bulk unit weight for any point on our spectrum, but at the ends of our spectrum, when the saturation is equal to 0, we have this special one called gamma dry, which is given by G on 1 plus E gamma W. And on the other end of our spectrum, when it's fully saturated, so all the voids are filled with water, we have this other parameter, gamma sat, which equals G plus E or 1 plus E gamma W. Okay, just before I finish, I'm just going to show you this other quick relationship. I'm not going to show you how we get it, but the bulk unit weight is the same as 1 plus M times by gamma dry. Okay, so just keep that in mind as well in the back of your mind. But the main things we need to see is this one here for gamma bulk, this one here for gamma dry, and this one here for gamma sat. In the next video, we'll be doing an example tying all these principles together, and I hope that helps.